yesterday. We got home at like 4 and I was just really tired. All right, guys, today we continue on in our polynomial unit. And if you look at our section title today, it says we're going to do something called factoring. Essentially, guys, factoring is like going in reverse of the distributive property. Yesterday, we spent a lot of our time distributing. Today, we're going to start going in the reverse of that process. And factoring is what we're going to spend the rest of our time in this unit on. So before we can get into doing that process of factoring, there's just a few basic terms that we have to make sure we refresh ourselves on before we can really dig in and fully understand that factoring process. So the first term, prime numbers. You might be like, oh yeah, I heard that once. Anybody remember what a prime number is?
Isn't it like positive numbers? Or no, it's 2, 4, 6, 8.
Those are even numbers. Numbers that? So like 3's a prime, 5's a prime, 7's a prime, 11's a prime.
It can't be divided by 2. Numbers that can't get multiplied together.
But they're all...
It's numbers that only have 2 factors, or numbers that can only be, let's phrase it a couple different ways. Numbers that, not that, let's rewind that. Numbers that can be divided by 1 and itself only. Or in other words, also another way you can phrase it, they only have 2 factors, 1 and itself. So prime numbers can only be divided by 2 numbers, 1 and the number itself. Or if you look at it from the factor standpoint, there's only 2 numbers you can multiply together to get a prime number. And again, that's 1 and the number itself. So you can look at it either way. So again, prime numbers, typically, they are odd numbers, but not all of them. 9 is an odd number, but why is it 9 prime? Because it can also be divided by 3, or 3 times 3 also gives us 9. So be careful, prime numbers aren't just necessarily odd numbers. There's plenty of odd numbers that are not prime. So just be careful on that. It only has 2 factors, or it can only be divided by 1 and the number itself. So if that's a prime number, then what do we consider composite? What do you think?
Numbers that can be divided by more than 1 itself.
Yeah, numbers that can be divided by more than 1 in itself. So can be divided by 1 itself and at least 1 more number. And I'm just using that little, it looks like a little hashtag. I'm just using that. That's my abbreviation for number. If you'd rather write out number, when I was growing up, it was a number symbol, not a hashtag. Hashtags didn't exist when I was taking math in high school. So composites can be divided by 1 itself and at least 1 more number. Or if we look at it from a factor standpoint, has more than 2 factors. Factors are things we multiply together. We're going to get to that definition next, because some of you are like, okay, Miss Golly, prime numbers have 2 factors. Composite numbers have more than 2 factors. So if we've been talking about factors, that'd probably be a good thing to define next. And just like when we looked at the definition of prime numbers and composite numbers, we looked at it from 2 different standpoints. What it can be divided by and what can be multiplied together. So we're going to also define factor in that same way. So if you have a factor, or factors I should say, factors are numbers multiplied together to get a specific number. Or a factor is a number that, let's see, phrase it for you guys, goes into another number evenly. Now, when I use that phrase goes into, I know that's typically kind of the more basic way to say division, or it divides evenly. So factors we can look at from, again, two different standpoints. The multiplication piece, if we multiply two numbers together, those are factors. Or if a number can go into another number evenly, those are also factors. So these top three terms, hopefully they're things that you've heard of before. I know when I said prime number, you're like, oh yeah, wait, I know what that is. Just can't quite remember. It's probably been a while since you've talked specifically about prime and composite numbers. Or even what a factor is. Or maybe a factor is a new one for you. Definitely the new one is our fourth and final term. It's a prime polynomial. I know you're like, okay, Miss Golly, when are we going to hit polynomials? We've been talking about polynomials all unit so far. A prime polynomial is similar to a prime number. It can only be divided by 1 and itself, or you could say has only two factors. So there's only two things I can multiply together to get that polynomial. Kind of up to you. Looking at all these definitions from that multiplication standpoint and that division standpoint. Because multiplication and division, they both fit for these types of terms that we're looking at. And then since the prime polynomial, since that idea is our newest one, we're going to focus specifically on that first. Remember, polynomials can just be one term or two or more terms that are added or subtracted. So when we look at number one, it says identify the polynomial as prime or composite. In number one, we've got three terms. We have a trinomial. I want us just to kind of keep hearing that vocab piece. As you look at number one, look at the number pieces. We've got a 9, a 24, and a 15. Is there a number other than 1 that could go into all three of those? What do you think? See a few people nodding your head, yes, yes. What could work? 3 could. 3 can go into 24, 3 can go into 9, 3 can go into 15. So this would be considered composite. And I'm just going to put a little note here. 3 goes into all three terms. Or phrase it something along those lines. 3 goes into all three of those things. Or all three terms can be divided by 3. 3 is a factor of all three numbers. However you want to phrase that. Now, as you look at question 2, 9 and 16. Do I have a number that can go into both 9 and 16? What do you think? No. No matter how hard we try, we're not going to get one that goes into both. And then the other thing we have to look at, do I have a variable that's common to both of those? No, I've got an m squared and nothing. So this one would be considered prime. So take just a minute here, based on what we talked about with numbers 1 and 2 and just kind of the definition up there. Write down what you think about number 3. If you think it's composite, put just a little explanation to yourself, like we did in number 1, why you would say it's composite. If you think it's prime, it's prime. So see what you think. Take a minute, jot down what you think. Prime or composite? What do you think? If you think composite, give just a little reason why. All right, guys, so what do we think? Prime or composite on 3? Okay, composite. Can somebody give me one reason it's composite? What do you think, Molly? Okay, so 3 goes into both terms. What else goes into both terms? What do both terms also have?
A.
They also have an A. Both terms also have an A. I know the one is an A squared, but that just means we've got an A and another A. So each term has at least one A. So 3 goes into both terms. So does A. Yeah.
That's 3 going to 24.
24 divided by 3 is 8. 24 divided by 3 is 8. All right, so now building upon that idea we just had, we're going to get our first taste for factoring today. We're going to do our very first method today. Factoring, guys, as I said earlier in this lesson, we're going in the reverse of the distributive property. So yesterday we spent a lot of time distributing. Today we're going in the reverse. I want to lay out a nice step-by-step process for you to follow to go in that reverse piece using this method, and then we'll put it into action. So as we go through those steps, if there's anything where you're like, oh yeah, I don't know what that means, we're going to do some examples together and illustrate each of those steps, okay? First of all, you might be thinking, Miss Golly, it says we're going to remove the greatest common factor. From here on out, I'm going to abbreviate that GCF. Greatest common factor means greatest common is going to be our biggest factor that can go into everything. Okay, so it's not just necessarily, hey, 3 goes into everything. We need the biggest, we need the greatest, we need the largest that can go into everything. We need the biggest factor. All right, so first of all, we start off, if we're going to use this method, we want to find the greatest common factor of the coefficients. Or in other words, the numbers. So I want to find the biggest number that can go into every term in our polynomial. And again, GCF, I'm abbreviating greatest common factor there. Greatest common factor is going to be our biggest factor. What's the biggest number that can go into all of our terms? Once you've looked at your numbers, we're going to do like we just did in example 3. We also need to look at the variables. So we're going to find the greatest common factor of the variables. And I'm going to put a little side note here for that. The greatest common factor for the variables, and again, every term would have to have that variable. You're going to use the smallest exponent. And again, I will illustrate all these steps. I just want to make sure you have one spot that you can look to kind of walk you through this process. If you're stuck on a question, you don't know where to start at the beginning. All right, so we're going to find the greatest common factor of the number pieces. We're going to find the greatest common factor of the variables. Then what we're going to do is we're going to divide every term by our greatest common factor. We're going to divide every term by our greatest common factor, whatever we find it to be. We're going to write the answer as a product. You're going to have the GCF out front, and you're going to have some leftovers in parentheses. And we will see this again. We will illustrate every piece of this, I promise. What you have to do last is what we did in our first 3 examples. You have to make sure the answer, your final answer, is actually prime. So you just have to go back and take a look and make sure that you did divide by the biggest number, or you did get the variables that you needed, whatever the case may be. Whatever the case may be. So this is our piece by piece. I want to do a couple examples with you, and I want to give you a chance to try a few examples before I turn you loose for practice. Okay? So let's walk through. So let's take a look at number 4. I always like to just kind of make a note off to the side of what my GCF is going to be. So step 1 says find the greatest common factor of the coefficients. Those are those big number pieces. I've got a 3 and a 9. What's the biggest number, if any? Could just be a 1. What's the biggest number that can go into both of those? 3 can. So I'm just going to make a little note of 3 here. That's step 1. What's the biggest number that can go into both of the numbers? We got a 3. Step 2 says find the greatest common factor of the variables. We have to use the smallest exponent because we have to make sure it's common to everything. So I have an x squared and I have an x. So what's going to be common to both is just going to be that single x. It's just going to be that single x. Both terms don't have an x squared. They don't have x squared in common, but they do at least have an x. So those are our first 2 steps. We're just finding that greatest common factor piece. Step 3 says we're going to divide every term by that GCF. When we do that, I like to draw a little division bar under every term so I don't forget any. And then underneath, I write my GCF. When we divide, now it takes us back to our exponent properties from last unit. And I would say by far, when we divided on our unit test, that was one of our strongest exponent properties that we knew the best. So let's start with our first term. 3 divided by 3 is going to give me 1. We can write it. We don't necessarily have to, but let's write it just so we know what happened there. And then I have an x squared divided by x. What happens with those exponents? We're really going to have a 1 on that bottom x. What do we do with the 2 and the 1? We subtract. So 2 minus 1 gives me just a plain x. If you want to write to the first power, you can. Again, mathematicians, we get kind of lazy. We don't usually write the 1 that's in front or the 1 for the exponent. And we'll clean that up when we write our final answer. Now we move on to the next piece. We have negative 9 divided by 3. What do we get?
3.
We get negative 3. And then what happens with the x's? Yeah, we end up with an x to the 0 essentially. So they do simplify out to a 1. They simplify to a 1. We still already have a 3 there, so we don't need to write the 1. We don't need to write the 1. So that's what step 3 means. We're going to divide every term by the GCF. Maybe you might want to make a note to yourself here that we subtracted exponents. If you needed that refresher on that property, maybe just to remind yourself, hey, that's how we got just an x to the first. Then step 4 says write the answer as a product. Product means multiplying. We're going to put our greatest common factor out front and what we just got after we divided inside the parentheses. So I divided, I'm going to put parentheses, GCF goes out front. So when we started this process, I said, guys, we're going in reverse of the distributive property. Does our final answer now look like something we should distribute? Yeah, and it should. Factoring, we're going in the reverse of the distributive property. Now, if we clean this up a little bit, how I would write this answer, if you were looking on my answer key, I would have just a plain x minus 3. But if you have it written the first way, you have that one coefficient, that one exponent. Guys, I'll never mark that wrong. You know your stuff. You know your stuff. So your final answer should look like something you want to distribute. The very last step says make sure your answer is prime. Well, as I look at my x minus 3, is there a number or variable that I could divide those by anymore? No, I'm stuck. I've got a 1 and a 3. Only 1 divides those. My first term has an x, my second doesn't. So I'm stuck. It's prime. That's our goal. That's the form we're going for with factoring. We went in the reverse of the distributive property. That's what we're going for. This is how we're going to spend the rest of our unit. We're going to be factoring in different ways. And then in our next unit, we're going to be using this factoring to help us solve equations and also to help us graph. So it's going to build in there. We just got to kind of hang in there as we build our background so we can put it into better use in our upcoming units. All right, so let's do the same thing for number 5. GCF. Here we go. I have a 6, a 3, and a 7. Is there anything other than 1 that can go into all 3 of those? No, we're kind of stuck because 7 is one of those prime numbers. And 7 can't go into 6 or 3. So we're stuck on the numbers. So I move on to the variables. Does every term have the same variable? Yes. I have to use the smallest exponent because not every term has an r to the third. It doesn't have 3 r's. So I have to use the smallest. Step 3 says divide every term by the GCF. And in this case, it just happens to be an r, and that's okay. You might not always have a number to divide by. That's okay. So remember, we're subtracting exponents. My 6 isn't going to change. There's nothing to divide the 6 by. So it's going to be 6, and then we get r to the what? Second. Yep. Subtract the exponents. There's nothing to change the 3. And then we just have left r. Yeah. You can put to the first if you want. Now, in the last one, I'm just going to have left a 7. The 2 r's, be careful. They don't cancel because cancel implies there's a 0 there. They simplify to 1. So 7 times 1 is just going to be 7. I don't have any r's left. Don't forget, after you divide, don't forget that step number 4. We need to write our answer as that product. So we throw parentheses around, and we put the GCF out front. Your final answer should look like something that if I gave it to you to start with, you would think to distribute. Again, we're going in reverse of that distributive property, so our final answer should look like something we would want to distribute. Let's try one more together. I want to give you guys a couple to try before I turn you loose for practice. All right, let's look at number 6. The numbers, we have 6, 3, and a 9. Do they have anything in common? What do you think, guys? 3, yeah, 3. Step 2 says look at the variables. I've got a w to the 4th, a w squared, and I don't have any w's. So is w common to all 3? No. So can I put w as part of my GCF? No. So now this one, all I can do is divide everything by 3. So what we have left is we have a 2w to the 4th, a w squared. If you want to put the 1 in front of the w squared, you can to show the 3 divided by 3. That's fine. And then we have a minus 3. Make sure you watch your signs. Negative 9 divided by 3. We're still going to keep a negative with that. Don't forget parentheses. GCF goes out front. Now, in number 5, I forgot the last step, and it's so easy to forget because I know the final answer, but I need to make sure you guys know how to check for it. The final step says make sure we're prime. So if I look at number 5, if I look inside the parentheses, 6, 3, and 7, they still don't have anything in common. And I have an r squared and r, and then my last term doesn't have an r. So we no longer have an r in common, so we're prime. On my number 6, I look inside the parentheses. I have a 2, a 1, and a 3. They only have a 1 in common. That doesn't do me any good. And then a w to the 4th, a w squared, and I don't have a w on the last term. I've taken out everything common. It's prime. So you need to make sure when you have your final answer that you truly have gotten the greatest common factor, that you don't have anything left in common. What I would like you to try out, go ahead and try out the bottom 3. I will slowly start putting answers up as I start seeing you guys do a few more. I'll slowly start putting those up so you can check as you go, and then we'll get you some time to practice. All right, I have number 7 up if you need to check yours. I'll get the other ones up in just a minute. I've had a lot of people on number 8. Miss Golly, I'm stuck. There's not a number I can divide by. That's okay. We didn't have a number we could divide by number 5, and we're okay. So, as you look at number 8, every term has an x, and every term has a y. Now, here's what some of us are missing in number 8. Here's what some of us are missing in number 8. If you've moved on to number 9, rewind to number 8 for me. As I walked around, I saw the same common mistake on a lot of papers. My first term is xy, and I divide by xy. Here's why I've been very careful to not say the word cancel, and I've corrected the people that have said the word cancel. It's true, xy, xy, yep, I could draw lines through them, but they don't cancel. What if I have the same thing divided by itself? It doesn't equal 0. What does it equal? It equals 1. So your first entry for number 8 should be a 1. When you divide, guys, things don't cancel. They look like they go away because they equal 1. So oftentimes we don't need that 1. But if there's nothing left, we need the 1. Double check the rest of your number 8. And then go ahead and try 9. All right, let's check out 9. I've had a lot of you asking, Miss Golly, did I do this right? I think I might have got 9. Let's see. Let's try it out. Okay, so what we have in common, it looks like a 5 in common. Everything has a W. And every term has a Z. All right, so now I know for some of us, we talked about subtracting exponents, but those coefficients, guys, we divide those. 10 divided by 5 is 2. Now, I made some of you nervous with, wait, but W divided by W, wait, Miss Gal, you said it can't cancel. You're right, it doesn't cancel, but W divided by W, it simplifies out to a 1. And what happens when I multiply by 1? Does it change anything? No. So I don't need to write the 1 there. I still have a 2 left, and I still have a Z left. It should still be a minus coming next. 5 divided by 5 is 1. If you want to write the 1, you can. WZ simplifies W's, it simplifies the Z's. What's left of that middle term? Careful, it's not nothing. It's a 1, yeah. It's a negative 1. Yeah. It's a negative 1. There's a subtraction there. There's nothing to take that subtraction away. So be careful, guys. Things don't cancel. If you end up simplifying everything like we did in the first term for number 8 and now the second term in number 9, if everything simplifies out, you're left with a 1. That term can't just disappear. It simplifies to a 1. Then the last one, we're going to have a 3 and then just a W because the Z's are going to simplify out. Don't forget, though, don't miss easy points on a quiz or test. Parentheses, GCF goes out front. Don't forget that final format of your answer. Your final answer should look like something you're going to distribute.